Hey, hi, welcome. It is Thursday and May 14th. And what we're going to be doing today is starting a new unit here on bonding. And yesterday, pretty much had the day off remediating some different things with a few people. And today, a new unit. So, bonding. You might remember this is actually where we went out and on March 13th, the last day that we were there in school. This was the lesson for that day, but I'm going to go over it again because I think it bears repeating. So, bonding. We're going to take a look at three major types of bonds. Ionic bonds, which are formed between electrons of metals and nonmetals. And here we have electron transfer. Whenever we're talking about bonding here, we're going to be looking at what happens to the electron in that bond. And in ionic substances, it is transferred from a metal to a nonmetal. Typical ionic substance would be sodium chloride, but also maybe something with a polyatomic ion like calcium carbonate. So, ionic substances. Covalent substances, where we have the electron shared between two things. So this electron is shared. Both of these things will tend to have very, very similar electronegativity. You remember electronegativity, and that electronegativity chart you have is going to come out to play again. So we're going to need that, and I'll probably should add one to one of these assignments here so you can print one out again. Something like carbon dioxide or water. So we have everything is going to be a nonmetal and fairly close in electronegativity. So nothing is able to take away an electron from anything else. So co as in to share valence electrons. The third type of bonding here is metallic. Metallic bonding is the mobile electrons that are between metallic atoms. So in a metallic bond, the electrons are mobile, and that is going to become one of the most interesting things about that is that the electrons are able to move, and these things will be solids. All right. Now, the first thing we're going to do is take a look at these three types with a little bit of detail. Characteristics of an ionic substance. How do I know something's ionic? And I've decided that this is something that I really want you to be able to do. So, something that is an ionic substance, it is a solid. These things are so tightly bonded together that they will tend to be solids. They are crystals, as in they have a repeating three-dimensional structure. And if you take a look, the examples I chose are some of my favorite crystals. These are copper crystals and probably copper sulfate. They are beautiful to look at, and they are definitely a repeating three-dimensional structure. They have high melting points. It tends to take a lot of energy to get them to melt. As a matter of fact, in lab, oftentimes we can't melt them. They have low volatility, as in they don't smell. They don't smell because they're so tightly bonded to each other, they don't escape. So because they don't escape, they don't smell. They're electrolytes. We've talked about what electrolytes are, kids, and those are things that conduct in water. Conduct what? Conduct electricity in water. The electrolytes in Gatorade primarily are sodium chloride, just table salt, a little bit of a potassium electrolyte in there as well. I think it's potassium phosphate. They dissolve in water, so water can overcome their bonds, and it will dissolve in water. Not all of them, some of them. We know this because we have a solubility chart. So just because it doesn't dissolve in water doesn't mean it's not ionic. They do not dissolve in oil, so that will never happen. Ionic things never dissolve in oil. And they are poor conductors. As a matter of fact, they can be used as insulators. They're poor conductors of electricity. This would be as solids. Now, whack-a-lacky point here, interesting thing, ionics will conduct when they are molten. So when they are molten, when they have melted, they will conduct. So a melted ionic will conduct. And that's because when they've melted, the electrons are therefore able to flow. So this would have to be a molten salt type of idea, way, way hot. So this is a very, very strange point, but I just thought I would list it there. that the molten ionics are able to conduct. All right, let's talk about things that are covalent or molecular. Covalent bonds, and I've used these little things. These are little water molecule models that I've got over there. Covalent bonds can be found in all phases, solid, liquid, or gas. So it's usually a good sign if it's a liquid or a gas that it might be covalent. And that's because these bonds will be longer and they will allow things to be farther apart. They have low melting points and boiling points. It takes less energy to separate them apart. So that lower energy, lower melting and boiling points. They are volatile. They will have a smell. Anything like gasoline is a covalent thing. Of course, foods are covalent things as well. Things that smell tend to be like ammonia. Nobody likes that smell. And of course, it's two nonmetals bonded together, and that covalent things are going to be perhaps volatile. They're non-electrolytes. They don't conduct. They never conduct. Pure water does not conduct. Did that as a demonstration with you. They may be water soluble. Depends on a second characteristic that we'll talk about later in the unit. They may be oil soluble, related to the same characteristic, and they are very poor conductors. So again, we don't see them conducting as a solid, liquid, or gas. So they're very, very poor conductors. Metallic bonds. This is our third type of bonding, and it tends to get a bit of a short shrift because there's not much to talk about it. Typically solids, as in I can't think of any that aren't solids because elemental mercury is not bonded, it's bonded to itself, but they typically are solids. There's some low melting metallic alloys though. They tend to have very high melting points and they tend to be, and this is the thing, they are conductive. They are conductive, so they will allow electrons to flow. As a solid. Typically, if you've ever been electrocuted, you are touching something that was metallic, and I'm not talking about a static charge, I'm talking about truly electrocuted. They're insoluble, so they are not water soluble, they're not oil soluble, and that they will not be broken apart by these things. And they have low volatility, so they have very little smell, very, very little odor. All right, so this would be a listing of characteristics of things that are bonded either ionically, covalently, or metallically. So in today's assignment, I'm just going to give you a list of things and ask you how, based on the description, do they appear to be bonded together? So it's all about identifying things because it's a bit of a ripoff that we don't get to do these things in lab. I'd much rather do this with you in lab, but since we can't, this is how we're going to do it today. All right, I hope this finds you well and you have no problems with the assignment. If you do have a problem, as always, let me know and I look forward to working through it with you. AP test takers, good luck on your AP test as you go, and that I have my fingers crossed for you. All right, guys, take care and bye-bye.